Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is delete nodes from linked list present in array. Okay, so the problem statement goes like this. You are given an array of integers, nums, and the head of the linked list, head. Okay, and you have to return the head of the modified linked list. Okay, after removing all the nodes from the linked list that have value that exist in this nums array. Okay, so for example here 1 2 3 were the nodes values that were existing in the nums array, so we should be removing all the nodes that are having those values. Okay, so these three nodes were having those values, so that's why we removed them and returned the modified linked list, which will be this linked list. Okay, similarly, if we see the second example, here the only value in the nums array is 1. So whenever a node is possessing a one value, then it should be deleted from the given linked list. Okay, so as you can see, we have deleted all the ones here. All the red ones are ones, so once they are deleted, the only linked list that will be remaining is this particular one. Okay, and we should be returning that, the head of that particular linked list. Okay, to be more specific. So this is what we have to do in the problem statement uh, to solve the problem basically. And let's have a quick look at the constraints also. So according to the constraints, the length of this nums array will be of order 10 raised to power 5, and each entry in this particular nums array will also be of the same order of 10 raised to power 5, and all the elements in this particular array are mentioned to be unique. Okay, and the nodes in the given linked list will be of range 1 to 10 raised to power 5. Okay, and the number of nodes basically, and the node values will also be in the same range of order of 10 raised to power 5. Okay, and the last constraint is that the input is generated such that there exists at least one linked list node that has a value that will not be present in the given nums array, so that after deleting nodes which are having values in the nums array, you will be left with at least one node. Okay, so these are the constraints. Now let's quickly think of an approach. Okay, so the very first approach that came to my mind after reading this problem statement was that, first of all, since we need to know that whether the current node's value is in the array or not, so we need to have a fast lookup. Okay, so fast lookup is needed for node values to be deleted. Okay, so this is one thing that will be required, and the another thing that will be required is that once we know that a particular node is to be deleted, then we have to update its link. Okay, updating links in linked list. So how I'm talking, what is this updation of links in the linked list, what it will help us to do. So see, let's say these are the nodes in the linked list. Okay, and let's say the middle one is to be deleted. Okay, the linked list end here basically, and I want to delete this one. Okay, I came to know that its value of this node is in the nums array, which contains the values of the nodes that are to be deleted. So I want to delete basically this one. So what I want to do is basically I want to update this link. Okay, so what I will be doing here is I will be removing this link and rejoining the previous node from the node to be deleted to the next node of the node to be deleted. Okay, so once I update this link, when let's say this was the head of the linked list, and when you will be traversing this linked list again, now you will be going from this path. Okay, okay, instead of going from this path. So this path is broken, you can say, or no longer existing. So that is how we will be deleting a node. Okay. And you might also ask that what if we want to delete the head of the linked list itself? Okay. So in that case, what we will be having is we will be having a new node. Let's say, let's call this dummy head. Okay. And initially your dummy head will be pointed to the head. Okay. And once you are at a node that is to be deleted, then its previous link will be updated. So this link will be gone and the new link will be updated to this particular path. Okay. So let me remove this green one so that it will be clear to you what is happening. Okay, now if you want to delete the head's link will be broken and this will be updated. Okay. So if you now traverse the list, then you will be going this way. See, first of all this node, then this blue one. Okay, then from here blue one to directly to this particular one, since this have also been deleted. Okay, these two nodes are deleted. Okay, so this is how updation of links help us to delete the nodes. Okay, so let's see how we have implemented this. And for the fast lookups, I forgot to tell you, we will be using a data structure called set. Okay, that helps us to find out whether a particular element is existing in it or not in order of one time. Okay, so if you want to have a value lookup in the set, then it will be easier for us to get it in order of one time. Okay, so let's see the implementation. For that I will be bringing the code to the board, and let's take a fresh slide for that. So this is the implementation. So I hope it's visible enough for you. Now without further delay, let's begin discussing what's happening inside the code. So as we discussed that we need to have fast lookups. In order to do so, we are using set. Okay, so to be deleted is the name of the set, which shows that the values inside this one will be the values of the nodes that are to be deleted. Okay, now we will populate this particular set or add values to it. So we will be traversing your given nums array and we will be adding the values one by one. Okay, to the set. Now once we are having the set ready, we shall begin the deletion process. Okay, so as I already talked about that we will be needing a dummy head. Okay, for dummy head, uh, then this dummy head will be made to point to the head, just like this. Okay, so this link will be there. So then once we have made it to point to the head, so this is for the situation when the head itself is to be deleted. Okay, that's why we introduced this dummy head. Okay, and then there will be one current pointer. Okay, you can say, and there will be one previous pointer. So what will this current and previous pointer will be doing is, so see, this yellow one was the current pointer. So it was doing nothing but just going one node by node in the linked list while we were traversing it. So this will help us in the traversal. Okay, and what will the previous pointer do? The previous pointer will be pointing to the node previous to the node which is to be deleted. Okay, or previous pointer will be initially starting along with the current pointer. So as the name suggests, it's pointing to the previous nodes whose links are needed to be updated. Okay, so now moving further, Then you will do a linear traversal. As I talked about, that this current pointer will be helping you to traverse the list. Okay, so until and unless your current pointer does not reach a null value, so it means that you end the traversal. This was a null value. Okay, okay, and until and unless this happens, or it means that your traversal ends, you will be doing the following things. You will be having a value stored of the next node reference. Okay, so basically this is for the updation of the link, so you should be having the reference of the next node always. So see, if you want to join dummy head and this node, so this node's reference would be needed. Okay, so you are storing it here. Okay, once you see that the node's value is in the to be deleted set, then you will be deleting that particular node. Okay, so delete the current node. So then for that we will be updating the link. Okay, next link of previous node. Okay, so this is what we are doing. Previous next is equal to the next node, so the current node is skipped. Okay, and else if it is not scheduled for the deletion, then your previous node will be updated to the current node. Okay, and current node will always be updated because we are moving one node by one node from left to right direction while doing the traversal. Okay, and then as dummy head was pointing to the head of the linked list, so we will be returning dummy head dot next. Okay, dummy head next was pointing to the head of the linked list, so that's why we will be returning that only. And that's how we will be able to solve this particular problem, and will be able to do the required deletions. Okay, and if we talk about the complexities, time complexity wise, this let's say the size of the nums array was a, and the size of this particular linked list, let's say, was b. So here we were doing a linear traversal while we were adding the values in the set. Okay, let me change color here. So as you can see, a linear traversal, so order of a it was. Okay, and then again a linear traversal was there, so order of b it was. So overall time complexity becomes order of a plus b. Okay, and since we were also using some extra space here, so as you can see here, so this was order of a, so space complexity wise it will be order of a. Other than that, we are not using any extra space, we are just using a couple of references of the nodes or variables or pointers, whatever you may want to call it. Okay, so these were the current node, the previous node, the dummy head. Okay, these were the nodes and the next node, or variables that we were using other than that. Okay, so these will be the complexities. If you are still having any kind of doubts or any queries in general, then you may ask your doubts in the comment section, and I really hope this solution walkthrough added some value to your journey of honing your DSA skills. Keep solving more and more problems, and I will be seeing you in the next video. Thank you for watching.